I have made 8 instances for 4 relays, for relay 1, relay 2, relay 3 and relay 4. To turn on and turn off, I have made 2 instances. Then again for relay 2, turn on and turn off. Then for relay 3, it's turn on and turn off. And for relay 4, it's turn on and turn off. So now let's set our circuit as per our requirement. Here I am using one ESP8266-01 module, and most of the time we have used GPIO 0 and GPIO 2 for digital input output, but here I am going to use GPIO 0, GPIO 2 and TX RX pin. TX is also used for GPIO input and output, and TX is known as your GPIO 1 pin, and RX is known as your GPIO 3rd pin. Means now we have 4 GPIO pins: GPIO 0, GPIO 1, your TX pin, GPIO 2 and GPIO 3 is your RX pin. So for this, since you know that this module used 3.3 volt at your VCC and CHPD pin, so I am going to use this voltage converter as well as your programming module. So using this module, I am also able to program this ESP8266-01. Fine. Now we need to design our circuit. Let's see. I have made one breadboard to have ground from this common ground pin, and I will set the ground exactly to your ground pin. And so what I am doing, I am providing ground to this module and VCC to this module. So this 5 volt will convert to 3.3 volt using this module, and it will provide 3.3 volt to your VCC and CHPD pin. And your extension for your digital pins are like GPIO 2, GPIO 0 and RX and TX. From these 3 and this one will use to drive our 5 volt relay module. So see, this relay module is provided with VCC, ground and 4 triggering pin. So for here in VCC will provide 5 volt and ground is your common ground. So we will use this relay board to turn on our devices. So to power up this relay board, this module, your Wi-Fi module, we will provide 5 volt from this buck converter, and the input voltage is a 12 volt adapter. Let me show you. I am using this adapter 12 volt 1500 milliampere. You can use any 1 ampere adapter to provide power supply, because here I am using an buck converter, so I need not worried about this, because this buck converter is set to output of 5 volt. This 5 volt and ground is common for all the modules. So I have connected common 5V and ground to your common 5V and ground. This one is your common ground and this one is your common VCC 5V, and 5V is coming from your buck converter and ground is provided over here. So now let's connect your relay driver. Let's connect your 5V. This is your common 5V connected to your board, and again your 5V, sorry, this one is your ground to your common ground. Now connect your triggering pin. So I will connect your fourth relay to your GPIO 0 number pin. Let me set it once again. Okay, that is okay. Your 0 pin, and third relay is connected to your GPIO 1, that is your TX pin. Second relay is connected to your GPIO 2. Your first or the fourth relay is connected to your GPIO 3, which is your RX pin. Okay, so here is your basic setup. Input of 12V will convert this to 5V, and 5V is provided to your relay as well as your Wi-Fi module. Not directly, it's given through this module, which convert to again 3.3 voltage, and 3.3 voltage is given to your VCC of ESP8266-01 and CHPD pin to enable. Now to give some extra effect to your project, let's connect a Bluetooth speaker. Here I am using this Bluetooth speaker. I find this little cheap and very good looking. So now it's connected. Close your let's power off your module. This has inbuilt mic, so you can trigger using this speaker only, Bluetooth speaker. Let me set a little closer. Okay, let's see, let's turn on. Okay, let's open our Siri and see is it opening our other app or not. Hey Siri, open Google Assistant app. Okay, it's working from Siri. We can go to our Google Assistant app. Then we will use our keywords to turn on the devices. So first keyword is okay Google, turn on my bedroom light.
Okay.
Okay Google, turn on my kitchen light.
Okay.
Okay Google, turn on my bedroom fan.
Okay.
Okay Google, turn on my kitchen fan.
Okay.
Okay, so now you have now you can see that all the 4 relays has been on. So connecting your AC devices over this terminal, you can control any of your devices. Right? Okay, let's turn off all the devices. Okay Google, turn off my bedroom light.
Okay.
Okay Google, turn off my kitchen fan.
Okay.
Okay Google, turn off my kitchen fan.
Okay.
Okay Google, turn off my kitchen light. Sorry, it's not been triggered. Okay Google, turn off my kitchen light.
Okay.
Okay Google, turn off my bedroom light.
Okay.
Okay, it's already has been turned off, so we will go for okay Google, turn off my bedroom fan.
Okay.
So you can try yourself at your home. I think it is so simple project. So let's thank our Google to doing all the stuff for us. Okay Google, thank you.
I'm happy to help.
Welcome to my code section. So this is the code you need to write in your ESP8266-01 module. And okay, let me first show you my Adafruit feeds which I have been set to. See, this is my dashboard. Let's go to our feeds. Okay, see, I have mentioned 4 relays as my 4 feeds. Fine, my feed names are relay 1, relay 2, relay 3 and relay 4. So these are the feeds we need to call in our ESP8266-01 module code. So now go to our code section. See, let's start with, I need to include these 3 header files, which will basically include ESP commands, and this is Adafruit MQTT libraries, and this is for client libraries. I mentioned 4 relay. As you can see, the GPIO 0 is your relay 1, and TX pin is connected to your or 1 number pin, means it's your 1 number pin, and GPIO T is your 2 number pin, and RX pin is your 3rd number pin. These 3 pins are defined as relay 1, relay 2, relay 3 and relay 4. Now you need to set up your home Wi-Fi network with your home Wi-Fi network. So this is my SSID and this is my password, SSID password. See, this is my username, and you need to specify your API key. Where you will get your API key? You will get your API key from here. Go to your dashboard and you'll see all you have mentioned here, and you need to click here. So this is your secret AIO key. So this is my AIO key, means your API key, and this is my user ID. From these two things, I will be able to call my feeds. So after that, we need to create our client for ESP8266. So for that, I mention here. So using your Adafruit MQTT client, we need to we need to we need to connect with our server, means our Adafruit server. For this, we need a port number, a server name, your username, and your IO key. So here we have mentioned all the things: the port number, server, username, and your key. After that, you need to subscribe what you have mentioned over here. So we need to subscribe. So this is your function which will subscribe your MQTT connection with your username and your feeds. See here, the feed names are relay 1, relay 2, relay 3, relay 4. So you need to specify your feed over here. As I have mentioned, my feeds are relay 1, relay 2, relay 3, and relay 4. After that, just define your function so that the code will get to know that function is written over here, and it will execute and compile. So after some delay, what we are doing, after some delay, we are defining all the 4 pins are act like your output pin, means your relay 1 is your 0, relay 2 is your 2 number pin, means your what means your TX pin, which is connected to 1 number pin, then your GPIO 2, then go back to relay 4, which is your GPIO 3 and RX pin as well. So we are declaring this all these pins as output pin. So as soon as we are declare output pin, we have given all the output pin as high, means in our relay side, uh, the relay will active only when it will find a low voltage, means a low will be triggered to get the relay on, and after that we will begin our Wi-Fi with our SSID and password and check for Wi-Fi is connected or not. For every 500 millisecond it will try to connect, and try to find out the status. Then we'll I am trying to mention or trying to subscribe my on off 1 button, on off 2, on off 3, on off 4. These all are mentioned over here. Whenever you are subscribing, you are mention all these names. These are your variables which are subscribing this feed. Like on off 1 is your variable, subscribe variable, which is subscribing feed relay 1. Then your on off 2 will subscribe to your feed number 2, which is your relay 2. Fine. After this, we'll mentioning, we'll iterate each and every time, and we will find the value over your MQTT at the Adafruit side actually. So we'll connect first MQTT, means your Adafruit server side, then we will subscribe. If the subscription is there, means each and every 500 millisecond it will read the subscription. Mean after each and every 500 millisecond or after every 5 second, we will try to find the data which has been written over Adafruit server side. Right? Then after finding the data, after finding the data, we will try to take that and we will try to compare each and every feed, that it is there or not. If it is there, then we will try to find and try to read the last data which have been set over here. Means let's suppose this is on of one. If I am using this one, let me squeeze this one. Okay, let's suppose this device one, and this is has been set to on of one. So let's suppose I am turning this to 0. So the last value will be read to as 0, and this will be your current value, and which is equal to our character. ATOI is used to convert the character into your integer value. Fine. So this 0 will be converted to 0 again, but it is in integer form. So relay 1 will be 0, means the digital, it will get on. Since we are in a opposite um, manner which is connected in your relay side, so whenever you are passing it 1, it will change the state and it will store 1 to your rel 1. And so like this you can turn on and off with your 4 devices. The same has been written for 4 relays. Fine. So you can see this is your connection side, and I think the connection side is little easy. There is nothing to escape. You can go and you can download all the circuit diagram and code for this section.